Hey there! In this video, we're going to go over a review, a very brief review, but a comprehensive one, of motion along a line. Basically, we're going to go back over where we've been when we're asked about the position, velocity, and acceleration, but only going in one direction, like moving along an x-axis or moving along a y-axis. So let's check that out. So I've given you this problem. Let x of t be an arbitrary function that describes the position of a particle that moves along a horizontal line. So we're moving left and right or right and left. There is other function notation that we use for the following as well. So sometimes we don't use x of t, sometimes we use s of t or f of x. So there's other notation that goes with that. That's why I put that there. Okay, what does x prime of t then represent? If x of t is the position, then x prime of t is very simply the velocity. That's it. So we're just kind of going through this and understanding what each of these things represent. And then if x prime of t is the velocity, then x double prime of t is the acceleration. And the reason for going over all of this and just kind of putting it and condensing it down in one little area is that it's all the same stuff when we get into vectors and two space or two dimensions. So the integral of x double prime, if we're at x double prime, going up one level would get us to x prime of t plus c. So the x prime of t plus c, which is the same as the velocity, right? So that would be your velocity function. And then the integral of x prime of t, if we're at x prime, we'd be heading right back to position. So the x of t plus the initial value, or that constant c, that's the same as the position function. Position. Then the integral from a to b of x double prime is a little bit different. Remember, we use the fundamental theorem of calculus. That would be the function level that comes just before x double prime, which would be x prime of b minus x prime of a. That's the fundamental theorem of calculus, the first one that is. And that would be also known as the change in velocity. So change in velocity. And that's over t equals a to t equals b. So the starting velocity subtracted from the finishing velocity, the change in the velocity. And if we integrate x prime of t from a to b, that's going to be equal to the next level up, x of b, be the position at b minus position at a. So that's known as the displacement or the change in position. So change in position, or, and I'll write this all out for you, the displacement. And that would be over t equals a to t equals b, whatever those units of time are. Okay, all right, let's keep rocking and rolling. What does the constant of integration represent in each of the above antiderivatives? So the constant of integration in this first one right here, in order from here to here, would be the initial velocity. So that's the velocity at the starting value. So that's the initial velocity. And that makes sense because if I plug in t equals 0 right here, then I'm going to be solving for what that c value is typically what that is looking for, assuming that we start out with no velocity, right? So that would be my initial velocity is usually what that represents. Not always, but usually. And then the initial position. Again, doesn't always represent that, but usually, right? So we're going to go with that. And that makes sense, though, on the graph, because at t equals 0, this is our y value for both of those. Describe how you know when the particle's moving to the left, moving to the right. Old school. Our particle's moving to the left when we're moving in the negative direction. So that's this way. That would be when x prime of t is less than 0. That's it. And we're moving to the right when the velocity, or x prime of t, is positive. That means that we're increasing in position. That's all. So again, a real quick overview of some of these ideas, and we go on, and then that'll be it. That'll be it. It'll be a quick video. Provide the two situations using inequality signs when the particle's speed is increasing. So speed is increasing when the sign of velocity and acceleration is the same. And to go over the why behind that, you'll want to check out everything in chapter 3 earlier in this calculus journey that we've been on together. So that would be x prime of t is greater than 0, and x double prime of t, that's the acceleration, is greater than 0. Or it could be that they're both negative. X prime of t is less than 0, and x double prime of t is less than 0. So both acceleration and velocity need to agree in order to have a speed that's increasing or to be speeding up. To have speed decreasing, you'd have to have opposite signs. So here that would be x prime of t could be greater than 0, but then acceleration would be less than 0. So that would be opposite signs. So that and that. Or we could have the velocity is less than 0 and the acceleration is greater than 0. And those make sense because if your acceleration is greater than 0, drop my pencil there, then that means you're being pushed in this direction. But if your velocity is negative, it means you're going to the left. So they're working against each other. So you're going this way, but you're being pushed that way. You're slowing down. Whereas if we're going in the negative direction and the velocity is pushing us that way, we're speeding up. Okay, so what do these things mean? Well, the absolute value of x prime of t normally is the velocity. Without the absolute value, that tells us what direction we're moving in. With the absolute value, that gives us the speed of the particle. And that's because I don't know what direction I'm moving in if I take the absolute value. If the number was negative, now it's positive. It's just how fast we're going. And then the integral of essentially speed would give us not the displacement, but just the distance. So I'll say the distance traveled over, and it's our time interval t equals a to t equals b. Okay, so why go over all of that? Because we're moving in one direction in all of these ideas. But when we get into our next part of this lesson, when we deal with velocity vectors and acceleration vectors, position vectors, speed, distance, we're going to be moving in 2 dimensions all over the place. But really, we're just kind of splitting up everything in terms of left-right movement and up-down movement, just like we did in parametric equations. All right, let's get there. It was a nice solid review. I'll see you in the next one. Peace.